Good afternoon, everybody. I thought it would be appropriate to talk about security and put a battle helmet on while we're on an aircraft carrier, because anybody ever done an ICO or participated in one, trust me, you should be wearing this while you're actually like, hey, somebody just emailed me something from an email address I've never seen before. This is coolico.com at the end. So it's, anyway, security is good fun. So we're going to take a presentation that talks a fair amount about cybersecurity and try and simplify it down for you. Here's one of the great challenges in decentralized cybersecurity is that we have this new thing. It's called the blockchain. Everybody knows it's immutable, it's trustless, it's censorship proof. That's fantastic. There's a little minor detail. Was the transaction intended? So what that means is if I borrow your private key and I do a transaction on the chain, did you intend to do the transaction? No. What evidence on the chain is there that I borrowed your key? None. There's just the evidence I did the transaction. I'm not going to say, well, you did the transaction, I didn't do it. So it's fascinating when you, for money it's easy, we just stole your money. But if I'm going to put your medical records on, who put the medical records on? What medical records did they put on? How do I know the medical records they put on were your medical records? What if they were fake medical records? It's an interesting challenge. So today what we have is just keys and instructions, and on the chain all we have is a transaction hash. We know the data was there and it hasn't been changed, we just don't know if the data was intended. So what we're trying to propose is an extension to the model of how we think about data on a chain to include, for example, an attestation hash. This is a technology out of things like trusted computing, hardware security, where we can take a picture of the rules and the process and the formation of the transaction you produce, and we can include a hash that proves that this device in this condition with these controls did that transaction. And we can store that on the chain. And so it's a really powerful toy to add to the picture because it's decentralized cybersecurity controls. It's your device, when it forms the instruction, actually including with it information about the thing that wrote the transaction. Like, did you write it with a Trezor? Probably is more likely that it was you than if it was written with a key that was written on a piece of paper. So what can rules be? Rules can be your biometric or your PIN matched, or maybe your device calls your mother and you're required for your device to call your mother before you can do a transaction. This would be great because your mother would get a phone call. I mean, there are all sorts of different things. Your rules could be, are you an employee still? I checked with the HR system to see whether you're still employed. Why is this important? Because at the end of the day, as we improve the quality of the information on the chain, the value of the information on the chain goes up. And so today, while we have immutable data and it's relatively simple, the opportunity is to dramatically increase the value on chain. And if we do that, now we can start to have transactions that came from a known device in a known condition with known controls that are immutable and haven't been changed, as opposed to just stuff we wrote in a database. So what's trusted execution? Inside the hardware of your phone, in the chipsets of your phone, is a second operating system, the ability to store and process secrets. It's how Apple Pay does Apple Pay. It's how Samsung does Knox. It's how your cable box does pay-per-view. It's a technology that's been around for a long time. It's very broadly deployed. It's designed to protect your private key and do instructions. It's been shipped on about 1.5 billion phones over the last 4 years, so we like to say we have about 750 million handsets available to us because we figure the first half of the phones are already in somebody's desk drawer wondering why the battery's dead. Right? So the opportunity is now turn this technology and enable it. So what we're doing is trying to bring those tools to work because trusted computing forms instructions, or you could say it, trusted computing operates tokens, tokens operate chains. By the way, what are the trusted computing devices you can buy here? Trezor or Ledger at the hardware desk, those are trusted computing devices. You have many different aspects. You have the ability for secure display and different types of inputs. And so providing those tools as part of the anatomy of a real transaction, which is what you see is what you sign, combined with the proper collection of user intent. How do I know this is the transaction I'm permissioning, like typing in a PIN number? protecting the secret of the actual transaction, and then some form of attestation that all those other pieces are actually working properly. Because what you want to know is that you actually saw the transaction that you executed. When you combine that with the potential for external control, so not only can I have that trust device that I carry around with me everywhere, protect the transaction here, but it could check other external sources, like, am I on the aircraft carrier? You can't get on the blockchain. That would be very useful if what you had is a whole bunch of aircraft carriers. So then this comes to the heart of it. And if there's any piece I can leave you with as a thought, as you look at blockchain projects and you look at all the claims they can make, ask a very simple question. What can they prove? Ask it of the founders, ask it of the technologists, ask it of the people looking at the system or the buyers of the token for the system. What can I prove? Well, I can prove this data hasn't changed. But can I prove this data was actually intended? It's actually even kind of cute to ask whether when you read the data from a chain, how do I know it came from a chain? Well, you got to read a lot of nodes. How many nodes did you read? I don't know. Were they real nodes? Were they fake nodes? How do I know? So cybersecurity ultimately is about asking that question, which is, what can I prove? So I'm going to wrap up here because they've shortened the time because we've been consuming your entire afternoon. And Rivets is a company that's bringing a new economic model. I'll leave you with one thought. The previous presentation was entertaining, talking about the aspect of cybersecurity, or of security tokens. Utility is this new business model for software. This is how we're going to pay for services and controls in the future world. And I'll leave you with one thought. Machines don't watch ads. Machines are going to need a source of money to pay for services because they're not going to watch ads. And if you expect your machines to be able to access this fantastic ecosystem that is the internet, you're going to need to give your machine an allowance. What you're watching here is the industry that's going to give your machine an allowance. And that set of tools is actually larger than the aggregate value of all the companies that you could, if you put all the stocks into a blockchain. Actually, all the revenue for all the services that we spend out there is a bigger number. So this is a modernization of how we pay cross-border globally for services in machine-level money. Thank you very much.